Alright, this is Algebra 2, Chapter 3, Section 2, Solving Systems Algebraically. So, in the previous section, we were solving linear equations, finding their intersection, the point where they intersect by graphing. This section, we're going to do three techniques. The first one is substitution, the second one is elimination, and the third one is by adding and subtracting. The third one is elimination by multiplying. So when we do substitution to solve, solving by substitution, that works when you have one variable already isolated. So in terms of solving this group right here, we have x plus 3y equals 5, and we also have negative 2x minus 4y equals negative 5. Well, if you look here, we already have a variable that's isolated for the most part. It's all by itself. So when you have a scenario like that, what I can do in this part is I can subtract the 3y from both sides and say that x is equal to negative 3y plus 5. So I've isolated the variable. Then I'm going to substitute it, hence the substitution method, for anywhere that I see x. So this guy is going to get substituted over here. So that's step 1. Step 2, I'm going to rewrite the second equation with the substitution. So negative 2x, negative 2 times negative 3y plus 5 minus 4y equals negative 5. Then I'm going to solve for y. And that gives me 6y minus 15 minus 4y equals negative 5. And I'm going to add 15 to both sides and combine like terms, and I get 2y is equal to 10. Divide both sides by 2 and I get that y is equal to 5. So that's my first step. Oh, made a boo-boo. This should be negative 10. My fault. This is still negative 4y. 3, 6, negative 2, 10. Yeah, my mistake. So this changes into adding 10 to both sides. So this is going to be 2y is equal to 5. Then I divide by 2 and I get y is equal to 2 over 5. So y is 2 over 5. Then the next step, I'm going to plug in this 2/5 into either one of my original two equations. I'll plug it into the top one. So it's going to be x plus 3 times 2, no, I'm sorry, 5 halves times 5 halves equals 5. Okay. Then that's going to be x is equal to 15 over, x plus 15 over 2 is equal to 5. I subtract 15 over 2 from both sides. Uh, this over here I can rename into a fraction and call this guy multiply top and bottom by 2 and say this is 10 over 2. Subtract 15 over 2 from both sides and I get x is equal to negative 5 halves. So then my answer would be negative 5 halves, or negative 2.5 and 5 halves. That's my first one. That's my second one. And this would be my ordered pair. Alright, so we substituted. We found a situation where the variable is by itself. I solved for that variable and I substituted that solution into the first one to find what that variable is. And the reason why we got to do this is because we can't solve for two variables at the same time. We have to solve for one variable at a time. So we either have to turn all the variables into x's or all the variables into y's. And since we have two unknowns, we need two separate equations. Okay, so this one here says an online company offers 15 downloads for $19.75 and 40 downloads for $43.50, and they have a one-time registration fee. So here's our equation. 15 downloads plus a registration fee for $19.75. And then we also have 40 downloads and that same fee also for $43.50. Again, both of these guys have an f that's by itself. It's not being multiplied by anything, so I can solve for either one. I just choose to solve for the first one because it's there. So I subtract 15d from both sides and I get 19, or f rather, equals 1975 minus 15d. And I'm going to substitute that guy for f over here into the second one. So once we do that, then we can say 40d plus 1975 minus 15d is equal to 43.50. This turns to 25d. I'm going to subtract 1975 from both sides. So it's going to be 350 minus, that gives me 2375. Then I'm going to divide by 25. And I get that the cost of the download is 95 cents, or 95 hundredths of a dollar. So that's my first step to find the, actually the first step was to isolate the variable. Next step, once I get that, I'm going to plug it back to either equation, it doesn't matter which one, to find what the fee is. So I choose the one on top. So 15 times 0.95 plus x equals 1975. This turns into 1425 plus f equals 1975. Subtract 14 for both sides. And I get that the fee is $5.50. So the download cost was 95 cents and the fee was $5.50. Again, this was substitution method. Yeah. We also have an elimination method, And the way that the elimination method works um, is that we can add or subtract equations. So here's the one that they give us. We have negative 2x plus 8y equals negative 8, and we have 5x minus 8y equals 20. So notice that they both have an 8x. I have an 8x here. I have an 8x here. Also notice that they have different signs. One is a minus, one is a plus. Since they have the same or different signs, I can eliminate, hence elimination method, the 8y's by adding my equations. So I'm going to add them together. Add them together. So, negative 2x plus 5x gives me 3x. 8y plus negative 8y, 8y plus negative 8y gives me 0y. I have eliminated it. And then negative 8 plus 20 is 12. So then I have 3x is equal to 12. And then I can solve and say, hey, this is step 1 right away. Add it and eliminate. 1. X equals 4. So we found our first one. Then we can plug 4 into either equation, either the first one or the second one. I'll choose this case to be different, the second one. 5 times 4 minus 8y equals 20. So this is 20 minus 8y equals 20. This turns into negative 8y equals 0, and I have y equals 0. So then my solution is going to be the x coordinate. So the x coordinate is 4 and the y coordinate is 0. And my solution will be 4, 0, 4, 0. Here's my y. Here's my x. Okay, so we notice that they had the same coefficient in front of the variable. They had different signs, so they would add. Had they had the same coefficient and the same sign, if this was a plus, then we would have subtracted this. We would have had to subtract, and it would have been negative 2 minus 5x. Negative 2x, and it would have been negative 8 minus 20. So when they're the same sign, we subtract. When they're different signs, we add them up. So that's elimination. And then we have the concept of an equivalent system, which means that we can multiply or divide to manipulate our equation, and the equations are still the same. So this is still elimination. But it's elimination by multiplying or using equivalent systems. So here's how this works. So here they give me 3x plus 7y equals 15. Here they have 5x plus 2y equals negative 4. I have nothing where I can easily add or subtract something. So what I'm going to have to do is I'm going to have to find a common number to multiply by. So I could either eliminate the x or eliminate the y. I'm going to choose to eliminate the y. X. I'm going to choose to eliminate the x. What I can do is I can multiply this whole equation by 5. Down here, what I can do is multiply this whole equation by 3. The reason being is that I'm going to have a 15x over here. I'm going to have a 15x over here, and then I can eliminate the x. So basically I'm using the distributive property, and I'm going to have a equivalent system or equivalent equation, and I'm going to call it 15x plus 5 times 7 is 35, 35y, and then 5 times 15 is 75. Down here, I'm going to do the same thing. I'm multiplying the whole equation by 3. 3 times 5x is 15x. 3 times 2y is 6y. Oh, this should be 35y. I don't know why I didn't write 35. 3 times 2 is 6y. And 3 times negative 4 is negative 12. These two guys are the same equation. They're the same. I just multiplied it by 5. Remember, what you do on one side, I do to the other. Well, in this case, I multiply both sides by 5. I multiply both sides by 3. These are equivalent systems. Now that I have both of the variables the same, 15 and 15, they have the same variable and they have the same sign, I can subtract these guys. So it's going to be 15x minus 15x, which gives me 0x. 35 minus 6y gives me 29y. 75 minus negative 12. So I have a double negative. So it's like saying 75 plus 12. That gives me 87. So then this is gone. I'm going to divide both sides by 29. And I get that y is equal to 3. So first step, create the equivalent systems. Second step is to use subtraction to eliminate the x variable, and then here we solve for y. So in this case our y is 3. After we find that, then we plug it into either one of the original equations. I'll just plug it into the top one. This one will be 3x plus 7 times 3 equals 15. So this gives me 3x plus 21 equals 15. Subtract 21 from both sides and I get 3x equals 6 and x equals 2. So x equals 2. So then my ordered pair for the solution to this guy is 2, 3. 2, 3. Wait. Almost 2, 3. I made a boo-boo. This is negative 6. This turns to negative 2. Yes, it's negative 2, 3. Negative 2, 3. Okay. When you do the elimination methods, you might come across two unique situations. So let's talk about those unique situations. Here for 5a, we have negative x plus y equals negative 2, and then 2x minus 2y equals 0. I'm going to multiply this first one by 2. So I'm going to rewrite these over here. That's going to give me negative 2x plus 2y equals negative 4. And then this is going to be 2x plus, minus 2y equals 0. So I'm going to add these. Here I have the 2 and this negative sign. I have a 2 and a positive in front, so I add these to eliminate. Negative 2x and 2x equals 0. 2y plus negative 2y gives me 0. Negative 4 and 0 gives me negative 4. So then my solution is going to be 0 equals negative 4. This doesn't make sense. And since it doesn't make sense, 0 can't equal negative 4. What does that even mean? Actually, that means that we have parallel lines. And since we have parallel lines, they're never going to intersect. So our answer is going to be no solution. No solution because they are parallel lines. In our last unique situation, here we have a 4x plus y equals 6. Here we have a 12x plus 3y equal 18. The top part I can multiply by 3. And I get 12x plus 3y equals 18. And on the bottom I have 12x plus 3y equals 18. Hopefully you noticed something. I subtract them because I have a 12 here and a 12 here, and they're the same sign. So it gives me 0x plus 0y equals 0. Then I have 0 equals 0. When you have a situation where you have a 0 equals 0, we're dealing with identical lines. And when you have identical lines or the same lines, one superimposed onto the other, or coinciding lines from the last section, coinciding lines, I'll give you that too. There are infinitely many solutions. Meaning you can plug in any number with the same number for y infinitely many times. So when it's 0 equals 0, they're coinciding lines, and there's infinitely many solutions. When it was like the previous one, 0 equals negative 4, then we have a parallel lines, and they'll never intersect, and it's a no solution. All right, that is our section. Hope you have a great rest of your day.